Good evening, everyone. My name is Faris Palingga, and here I'm going to explain the basic concept of algorithms. An algorithm is essentially a process or a set of rules that we follow to solve a problem or perform a task. It's like a recipe for cooking, like it tells you the steps to go from the raw ingredients, the input, to a finished meal, which is the output. In everyday example of algorithms, let's start by looking at how algorithms appears in our daily lives. Think about when you get ready in the morning, there's specific order to what you do, like brush your teeth, take a shower, get dressed, breakfast, and blah blah blah, each other things. And you won't do this randomly because that will be inefficient, right? And another example is searching for a book in the library. You don't just walk in and start looking at random. You probably have specific plan, like checking the library's catalog system, finding the right section, and scanning the shelves. This is like an algorithm because it's structured process to find what you're looking for in an efficient way. Even social media platform use algorithms to decide which post to show you first based on what you like, comment on, share. So algorithms are everywhere and we use them all the time without even realizing it. And next up, and talking about the structure of an algorithm, at its core, an algorithm has three main parts. The firstly is an information or data you provide. In the recipe analogy, this would be your ingredients. Secondly, this is the series of steps or operation the algorithms perform to work with the input. For example, like mixing ingredients, cooking them, and other things like that. And then the output, last but not least, is the output. This is the final result or solution produced by the algorithms in cooking. This will be your complete dish. In programming, an algorithm works on the same way and you give the computer some input. The algorithm processes it step by step, and then you get the output, which is your solution or result. And now next up is the characteristic of a good algorithm. But not all algorithms are created equal. So what makes a good algorithm? First is clarity. Secondly, efficiency. Three, correctness. And last but not least, the fourth is finiteness. So clarity is like a good algorithm. A good algorithm should be easy to understand and follow. It's like writing a clear instructions. If your recipe is unclear, you'll end up with a mess. And efficiency, the steps in the algorithm should be as short and direct as possible. In computing, time and resources are valuable. You don't want your algorithm to take longer than necessary to get the result. Third, we have correctness, and of course, the algorithm has to work correctly. It should always give the right output or any valid input. And last but not least, the finiteness. The algorithm must finish after a certain number of steps. If the process goes on forever, you'll never get the results. So every algorithm should eventually lead to a solution or an answers. So what is the algorithm in programming? In computer science, algorithms are the heart of programming. When you write a code, you're essentially telling the computer to follow a specific algorithm to achieve a task. Whether you're sorting a list of numbers, finding the shortest path in Google Maps, or even playing a video game, there are algorithms at work behind the scenes. For example, think about sorting algorithms. Imagine you have like a list of random numbers and you want to arrange them from the smallest to largest. There are different ways to do this, like bubble sort, merge sort, or quick sort. Like each sorting algorithm has its own way of doing the job, and each has different strengths and weaknesses depending on the situation. So choosing the right algorithms for the job is really important because it can impact how fast and efficiently your program runs. That's why in computer science, learning about different types of algorithms and when to use them is a big part of the curriculum. And algorithms also have countless real-world applications. For instance, search engines like Google use incredibly complex algorithms to find the most relevant results when you search for something. These algorithms consider hundreds of factors such as keywords, use behavior, and website popularity. Another example is encryption algorithms that keep your data secure online, whether you're shopping, banking, or messaging. Encryption algorithms protect your information from hackers. Even recommendation systems on platforms like Netflix or YouTube use algorithms to suggest shows or videos you might like based on your view history. So the conclusion is algorithms are the backbone of not only programming but also many aspects for our everyday lives. First, from simple tasks like finding the fastest route on a map to complex the operation like data encryption, algorithms help us solve problems in a structured and efficient way. Hopefully have a better understanding of what algorithms are and why they're so important. If you want to learn more about specific types of algorithms, feel free to explore topics like sorting, searching, and optimizations. And this all for today, and thank you.